Hello and welcome to C# 103, Week 5. I'm going to be here. Mr. Jason Busby is going to be here.
Mister, what? You're just dying to make me old today. Okay.
And so will Mr. Gavin Whitlock.
Nah, he does that all the time. Hello, Mr. Nelson.
Hello.
It's like Mr. Ed, this. It's all very strange. Anyway.
Alrighty.
C#.
C#.
What are we going to do this week?
Today we are going to be covering the final bit of new syntax that I wanted to go over in this course. And that's going to be some things that people tend to not know very well. And I'm kind of surprised, though, that these sort of topics, they're typically introduced at an earlier level of C# programming, but on the same token, they do have a lot of really interesting implications as far as how you write your code. So we're going to be talking about operator overloading, conversions, structures, equality members, and indexers. And
cool.
Yeah.
I mean, like you say, it's that, we've talked about this before, that balance between when you learn something, like how long you've been programming, and how much you need to already know to actually understand. And there is that kind of, we reached the point now where we're starting to look back and go, well, you know, these things that we've said work like this. Well, they do, but they also do this.
Right.
And things get fun. And there are those areas that I've found this a lot as well. You get set in your ways, particularly as a beginner, I find, of you found a way that works to do something, so you never investigate other ways that might be available. LINQ's a good example of that. I hated LINQ when I first started because it looked horrible and it all looked different. But and I was quite happy. Why wouldn't I use if statements and, you know, for each loops and so forth? Mm-hmm. And it's kind of like that. Until you actually force yourself to try something out, you don't know whether it's going to be more help to you.
Yep. And especially once we start getting into structures. Structures are a very sort of weird thing in C#. And they have a lot of limitations. It's not like C++ where the difference between a class and a structure is pretty much just the keyword and default accessibility. Structures in C# have a lot of things that we're going to have to discuss, and now we have a bit more context about how to actually discuss those options, or those different things you can do. All right, so let's go ahead and fire up Visual Studio.
Cool.
Yeah, and equality is a really fun topic. There's a lot of different considerations you're going to have to keep in mind when working with equality.
And you're not allowed to follow Segfault's suggestion.
Okay, so the first thing we're going to be talking about is going to be implicit conversions. More specifically, user-defined implicit conversions. So for example, what we have here is an example of an implicit conversion. The integer literal 20 gets implicitly converted into a float. You know it's implicit because, well, you don't have to specify anything, well, explicitly. Unlike if I were to have done this, which is going to cause a problem, because there is no implicit conversion from a double to a float, like we've already talked about. In the case between a double and a float, however, there is an explicit conversion. I may do this by doing a cast. So line 12 is an example of implicit conversions, line 13 is an example of explicit conversions. But these are the built-in conversions. We can actually do our own conversion operations, or our own user-defined conversion operations. So before we move forward, I'm assuming everybody's pretty comfortable with this sort of syntax, the idea of implicit conversions being implied, and explicit conversions requiring a cast. Okay, so let's talk about explicit or user-defined conversions. So let's say I had a class called vector2 and a class called vector3. And vector3 is going to have public float x, public float y, public float z. And vector 2 is just going to have x and y. And then, of course, we'll give them a nice little constructor for int float, what? For demonstration purposes, blah, 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 blah. I want my resharper back. Float z equals z. Okay, so let's say I had a function that took in a vector 2. So static void, I don't know, maybe it's called, I don't know, size console window or something like that. It takes in a vector 2 because the dimensions of a console window are in x and y. So let's say that we had code. So at this point, everything is fine. Really, like the syntax I'm about to introduce isn't going to allow you to do anything that was previously impossible. Because if I had, for example, maybe a method static vector 3 gets information from database or something like that that returned a new vector 3. And of course, the signatures of these methods matter, their implementation does not. Okay, what should go here? What should go here? What code should go here to get the behavior that I'm looking for? I'm looking to pass this vector 3 into the size console window method. What should the syntax look like?
And we have a winner.
So typically at this point, what we would have to do is say new vector 2, vector 3x, vector 3y. And we're explicitly telling the compiler that because these types are not compatible. See, that's another interesting thing about object-oriented design, where types are not, just because one's called vector 2 and one's called vector 3, there is absolutely, at this point, no correlation between the two. Absolutely none. The C# compiler simply sees two different types with two different sets of properties and two different constructors. So what we have to do is we have to do our conversions neither implicitly nor explicitly. We have to do our conversions manually at every single individual call site of every method that we want to invoke with a particular conversion. So user-defined implicit conversions are not surprisingly a way in which I could pass this vector 3 into a method that takes a vector 2 and have the vector 3 decide how it's to be converted into this vector 2. We get an implicit conversion without having to specify any additional syntax. So to do that, if I jump into my vector 3 implementation, I can do this. And this syntax is going to look a little bit funky for now, but I'll explain it obviously. So it's going to be a public static implicit operator. Vector 2, vector 3 RHS.
Royal Horticultural Society. RHS is the Royal Horticultural Society. That means right-hand side, obviously.
Yes. I want everybody to type out these classes. Specifically this. Actually, I'm going to go ahead and add another implicit conversion. Public static implicit operator vector 3 vector 2 RHS. Return new vector 3 RHS X, RHS Y, RHS, or sorry, just 0. So go ahead and hit participate and get this code working. And the reason why is this syntax is so ridiculously awkward that I at least want people to have the opportunity to type it out at least once during the course of this class. So go ahead and get that typed out. Resume, and we're back. So yes, what we have here is an implicit conversion from vector 2 to vector 3 and from vector 3 to vector 2. An interesting note about how these work is, for sake of clarity at the moment, well, let's just go ahead and break these down, actually, before I get into that caveat. All implicit conversions are like this. They are all public, static, implicit operator, followed by the type that it's going to be converted to. Think about this as the return type of the method. Now, the reason I wanted people to type this out is this does not look like a normal method, and you will forget this syntax. Undoubtedly so. You will forget the syntax, because it is a very odd bit of syntax. The parameter list may only have the thing that's going to be implicitly converted from. So in this case, we have an implicit conversion between vector 2 to vector 3. An interesting side note, though, is that the requirements for conversions is simply that the enclosing type is either the return type or on the parameter, meaning that I could have just as easily defined both of these implicit operators within vector 3 if I wanted to. But obviously I couldn't create something like public static implicit operator int float whoa. Obviously that doesn't type. That doesn't make sense.
So basically, one of them has to have the conversion operator on it, but it doesn't matter which one, and it doesn't matter in which direction.
Right. As long as it's of the enclosing type. So this works because the parameters are the enclosing type. This works because the return type is the enclosing type. And so now we can go back and forth between vectors as much as we want. A few more interesting things about implicit conversions. Implicit conversions follow the exact same bit of stuff as normal implicit conversions. Meaning, if I did something like vector 2 vect equals new vector 3, this will work. This is an instance where implicit typing will actually prevent us from doing this sort of syntax. On the same token, though, I wouldn't recommend that, because implicit typing is obviously, we've been through this quite a bit. You should always use implicit typing. So to do this with implicit typing, you would use something like that. Now notice how I was able to do an explicit conversion, although I only define the implicit conversion operators for this type. See, if I were to remove these implicit conversion operators, I'll get an error. Cannot convert type from vector 3 to vector 2. An interesting side note, however. Can anybody tell me why this code compiles? And can anybody tell me the output to this program? So why does this code compile, and what does this code print? All right, we got a 1, 2. Keep in mind the definitions of the classes as they appear at the moment. Crash because of null. Now remember, this code does compile. It is completely valid code. So if I go ahead and hit F5, we don't get a null reference exception. We get an invalid cast exception. That's because what we're doing here is we're performing two conversions. Every object may be everything may be cast into an object. Well, practically. Of course, there are exceptions. There are.
How about everything that we define?
Yeah, everything that we define will always inherit from object. Of course, like I said, there are exceptions to that, but really don't want to get into that right now. But typically, it's useful to think that any type can be converted into object. And once you're in an object, you can go from object to any type by using an explicit conversion. Now, you can't go from object to any type using an implicit conversion, but you can tell the compiler You can say, well, I'm pretty sure that this is going to work, so go ahead and do it for me. And the compiler will say, okay. And then the runtime will say, well, what are you doing? And throw an exception.
That makes sense.
Okay, so implicit...
Basically in converting the vector3 into an object, you've lost any idea of what its X, Y, and Z are, because the object doesn't have those. And then by converting on, it doesn't know what to put there.
Yeah, and there's no code written that's going to allow me to go from a vector2 to a vector3 either, because there aren't any conversion operators. It's not because of Z, it's because of an invalid cast. Now keep in mind, this code doesn't compile at all. If I take off that object cast, this code will not compile. And the reason it won't compile is because the C# compiler knows that there is no conversion from vector2 to vector3. However, the C# compiler does not know that once you have an object, if it's a vector3 or a vector2. So we're able to sort of trick the compiler into allowing us to do something dumb.
Now, if there were default values on the vector2, would it then be okay?
No.
Because the constructor never gets called.
Yeah, without any code telling the C# compiler how to handle a conversion between a vector2 and a vector3, there's no way for it to perform that conversion, and it just dies. Unlike, like someone pointed out with C++, if we were using pointers, would let you do this. It wouldn't throw an exception, and you would be then pointing at an object through sort of the guise of another object, but you'd be pointing into other objects' memory, and you would get really strange behavior. Okay, so is everybody good with implicit operators? There's not a whole lot more to say about them. Implicit conversions are very easy to understand. The only bit is, remember, public, static, public, static, operator, no, implicit operator, type to convert to, parenthesis, type to convert from, parameter name, and body. Of course, it's going to, because I'm not returning a value, but still, if I were to return a value, that would work.
Cool.
All right. So that's an implicit operator, or implicit conversion. Let's talk about explicit conversions. An explicit conversion is, well, a conversion that you must specify explicitly.
So presumably this has basically the same behavior, except you can only do it by bracketing it.
Right. Yep. So while an implicit conversion will implicitly also handle explicit conversions, an explicit conversion may only handle explicit conversions. So let's notice some interesting things about this. First of all, I'm going to go ahead and write this explicit operator properly, RHS-X, RHS-Y, and then I'm going to add the other way, explicit operator, vector3, vector2, RHS, return new vector3, RHS-X, RHS-Y, and 0. Notice how now this code works. I'm able to explicitly convert from a vector2 to a vector3. If I were to have a method that, let's say, void blah, that takes in a vector2, and I had a var vector3, if I try to invoke blah with a vector3 without doing any casting, notice how I get an exception. It says cannot convert from vector3 to vector2. So we don't have implicit operators, but what we could do is we could say, I want to explicitly convert this vector3 to a vector2, and we get the appropriate result. So explicit conversion operators allow you to use a cast operation to go from one type to another. This leads into a discussion of why not make everything implicit? Well, the answer is, just like with C#, or just like with all the base types in C#, you should only ever do implicit conversions when there is no loss of data between the conversion. Given that criteria, which one of these operators should be explicit and which one of these operators should be implicit on line 38 and 33? Which one should be explicit, which one should be implicit? Think about it. From a design perspective. Now, obviously, they both can be implicit, or they both may be explicit. But given that the reason there's a difference between explicit and implicit conversions is just for increasing the readability of your code by documenting, I suppose you could say, instances where loss of data may occur. So, for example, when you go from a float to a double, when you go from a double to a float, loss of data may happen. Because of that, there is no implicit conversion from a double to a float. However, when going from a float to a double, there can be no loss of information, which is why the conversion is implicit.
I'm intrigued. I think Segwall's got it wrong. And now that has me worried that I've got it wrong in my head. Ah, no, he says he's wrong. That's good. I was like, that makes no sense.
There's only one operator that loses data, and that's this. This operator loses data. It loses the z component of our vector 3. Now, this operator does fill in some data, sure, but it doesn't lose any data. Which means that in a better design would be to make this operator implicit.
Wow. IMP. Yeah, there we go.
So into float is implicit due to no loss of data. Correct. Okay, so...
Which makes sense, because basically you want it to tell you, you want it to basically stop you and go, hey, hang on, you're losing data here.
Yep.
So you want that to be explicit, to force the user to explicitly do it. Otherwise, if it's fine, then you can do it behind the scenes, i.e. implicitly.
Right. And by specifying the explicit operator, now true, it doesn't give you, I mean, the explicit operator, the difference between an explicit operator and a method on vector 3 that returns a vector 2 may seem a little bit ridiculous as far as defining...
Although they're doing essentially the same thing, you're actually saying, you're explaining more the reason for its existence by using the operator, surely.
Right, because I'm using a bit of syntax built into the language itself to express a particular concept, and that concept is the concept of conversions. Okay, so given that we have an explicit conversion from vector 3 to vector 2, and an implicit conversion from vector 2 to vector 3, what is the output of this code? Notice how I added back in this object cast.
So,
People feel that it could be a trick. I would never trick you guys. When have I ever given you guys a trick question?
is that a trick question?
Okay, when I hit F5, look what I get. Which kind of doesn't make sense. It does make sense if you think about it, but it doesn't make sense off the top of your head. Because look at this. It says, unable to cast object of type vector 3 to type vector 2. Well, you can look at the code and just bang your head against the monitor saying, well, there is a conversion from vector 3 to vector 2. It's right here. I'm staring at it. In fact, if I were to take off this object conversion and simply leave a vector 2 cast, the code will work. What does this behavior prove about the nature of conversions? You okay?
Nothing. I was just going to mention something that's basically the answer to that.
This actually proves something. Come on, can anybody... This proves one very important thing. It's a very important concept that we've talked about for the last 2 courses that's really important to keep in mind. True. No, ignore that.
Wow, he's got good eyes.
Yeah. Okay. Segfault, do you have any guesses as to what this proves? Oh, actually, he already kind of answered it. This proves that implicit and explicit operators only work during compile time. They do not work during runtime. At least user-defined conversions don't, in this particular case. So, for example, if I were to have a static void ble object woe, and I said var vector 3 equals vector 2 of woe, or sorry, wow, that was weird. Vector 2 equals vector 2 of woe, console, write line, vector 2 dot x. And if I was to go ahead and invoke ble with a new vector 3 and run this code, we get an invalid cast exception. User-defined conversions do not work at runtime, which makes sense.
Yes.
If you think about it.
Because by the time you get to runtime, well, you're not dealing with anything user-defined anymore. You're dealing with the runtime. Does that make sense at all?
Yeah.
Yeah. I mean, I'm hesitant to say it in case I've got it completely wrong. But basically, surely by the time we're at runtime, any user-defined types have gone away because they're compiled constructs.
True, but it would be possible for that information to be compiled into the metadata, but though regardless, it still doesn't quite work like that. It's not able to, using this bit of syntax, you are not able to perform any sort of runtime checking or runtime conversions. User-defined runtime conversions, that is.
See, in this case, I'm going to side with Wolf Knightley. His question, what did ble prove to us and how?
Well, it proved to us that there's an error that happens when doing a runtime conversion, whereas there isn't an error when doing a compile time conversion. So, for example, by doing a compile time conversion, I can do this. I can say var hey equals vector 2 new vector 3. This works, and the reason this works is because this is known at compile time. At compile time, the C# compiler looks at this and says, okay, well, you're trying to turn a vector 3 into a vector 2. Does the vector 3 or the vector 2 contain any conversion operators that will allow this to work? if it does, replace this code with basically this code.
Your compiler has a silly accent.
So what happens at compile time is this code gets translated into this code. Derp. So how's everybody feeling?
That makes more sense.
Yeah. How's everybody feeling about this? So what's line 58 attempt to be changed into? Line 58 gets turned into, I can't remember the opcode for it. Well, it basically gets turned into this. If vector 2 is vector 2, or sorry, if not vector 2 is vector 2, then throw new invalid cast exception. Otherwise, or sorry, if woe is vector 2. Otherwise, set vector 2 to woe. Now, of course, there will be ways to do sort of runtime conversions on stuff, but it gets a lot more complicated.
Do you see what Wolf just asked?
And in Bleh, that doesn't happen because it doesn't have a new vector 3. Kind of, sort of. In Bleh, it doesn't happen because the compile time type of the parameter is an object. And basically what happens is this is the runtime code, by the way. Here's what the compiler is thinking. The compiler is thinking this. Okay, or what type is woe? Does the compile time type of woe have a conversion? Well, it's an object, so no. Whereas with this code, let's go ahead and alias this out into a variable real fast. Here's what the compiler thinks about this code. It says, what is the type of vector 3? Does the compile time type of vector 3 have a conversion? Indeed, it does on line 33. See,
fantastic.
So this is the compile time type stuff. This is the runtime stuff. And they're all going to be different because runtime stuff is code that has to run at runtime, whereas compile time stuff is code that happens at compile. Now, why can't the compiler know if there's a conversion from woe to a vector 2? Why can't it know that? Well, like people said, it's because I can pass anything. I don't know. Let's pass in a new object. And then let's pass in, I don't know, a new stream writer. I can pass anything I want into Bleh. Anything. Because the parameter of woe is an object. So because I can do that, the compiler cannot know for certain if any implicit or explicit conversions happen at compile time. Is it possible to cast the type with a generic. So something like this. What's going on here is when you try to do an explicit conversion with a generic type, you run into a situation where, think about it. I'm going to take off this because that doesn't work. Think about why this doesn't work. I've made ble a generic method, and I have a generic parameter. But the reason why line 72 doesn't work is actually pretty straightforward. Because think about this. When line 59 gets invoked, okay, line 59, everyone, we're passing in an integer. This becomes an integer. Is there a conversion between an integer and a vector 2? No. Line 60, we're passing in a string. The method becomes this. Is there a conversion between a string and a vector 2? No. Line 61, we're passing in an object. Now, at this point, there is a conversion between vector 2 to an object. Not necessarily a conversion, but a possible cast, or a potential cast. So there's no way to get around this with generics. In fact, by adding genericism, what we have done is made the code not even compile. Because now the compiler says, well, T can be anything. And if T can be anything, I can't for certain tell you if you can do this conversion. And that's how the C# compiler generally does business. It will not let you do something it can't logically prove is possible, typically speaking, unlike certain compilers of certain languages.
Certainly.
Yes. Why is object a runtime thingy?
Is that a technical term?
Well, I use thingy all the time too, to be fair. Object is no more a runtime thing than a vector 3. The difference is that because almost all types inherit from object, we can pass in anything we want. So it becomes, instead of a cast that can be known, we have a cast that can be unknown.
So any more questions about this, what we've covered so far?
So it's almost like generics. It's similar. You can sort of, basically, whenever you see the word object, that's a lack of generics, actually. It's funny. So, I mean, I'm not going to say that object has any relationship to generics because that's not technically true, but conceptually, you can think about generics as a type-safe way of doing stuff with any type. And you can think about object, using object parameters, as a non-type safe way of doing anything with anything. Because the whole idea, the whole reason why generics were invented was so that we didn't have to do this. See, way back when you wanted to make a method, back in C#1, when you wanted to make a method that could take in any type, you would be forced to use an object parameter. But now with C#2 and the CLR version 2, you can have generic methods that can take in anything without relying on runtimeness.
They're kind of like arriving at the same, using object and using generics, kind of like arriving at a similar place from opposite directions, it seems to me. Because with object, you're basically stripping it down to the bare bones of what it exists, presumably just like toString, and that's about it. And even that will be fairly nondescript. Which would be like taking a car and saying that it's composed of 4 wheels and a seat. You know, it's the absolute bare minimum that you can get away with. Whereas generics allows you to specify different behavior for different things, really. It kind of does the opposite. You're specifying that it can have everything with every option, and heated windows and giraffe sunroof.
Yeah, and with generics, though, you are constrained on doing things, like we saw before. This code sucks right here. This code is bad. This code is bad is because we have introduced compilable code that could easily and most likely will throw an exception on line 72. Using generics, we wouldn't be allowed to do this. I can't do a bleg2 and a blet2 and use a generic parameter and cast it to a vector2. There's no way for me to do this. It's impossible.
You would have to specify it yourself elsewhere in code. I.e. in vector, you'd have to provide the conversion.
And as far as generic type constraints, yes, I could do where t is a vector2. This code is, then now what's the point of using generics?
Well, you could...
In this case.
You could have where t is, yeah. There could be many types of vector2.
So the cool thing about generics is it prevents you from doing stupid things and will ultimately result in you refactoring your code to what this method should look like. This method should look like this. Actually, can anybody tell me what the method ble should look like?
You just clarify what you want it to do again. Because in between all the comments and things are different ways of doing the same thing.
I wanted to print out vector2.x. That's all I wanted to do. Ble should look like this. There's no reason for me to use any sort of polymorphism or casting for this method whatsoever. It's pointless. But by doing this, we can now take advantage of implicit operators and explicit operators, whereas previously we couldn't. Alright, so any more questions about implicit and explicit conversions? Because I actually only intended this to take 10 minutes.
So we're probably about on schedule then.
Yeah. Why does Resharper not warn that casting line 72 could be wrong? Not asking why Resharper does, but why do you feel it won't warn you? Resharper typically doesn't... I don't think I've seen Resharper warn me when doing explicit casting like this. And I think the conceptual reason is per definition, an explicit cast is, hey, compiler, get out of my way, I know what I'm doing, do this cast for me. If it fails, I'll deal with the consequences at runtime. Well, it's... Well, yeah, this is a case where I'm doing something stupid. But a cast is a way to acknowledge that you're doing something potentially stupid, or potentially not stupid, depending on what your code looks like. A cast is a way of saying, I know that I want this code to work like this, and I am reasonably certain it's going to be correct. Stop bugging me, compiler, stop bugging me, Resharper, and let me do my own thing. That's what a cast is. Or that's what more specifically, that's what a downcast is. When I'm converting from a less derived object to a more derived object, or whichever way around that's supposed to go. Okay, so you should show how to look, but what are you passing into it? What I was kind of pointing out with this method, this ble3, is that it should look like this because this spells the intent of the method more. You should avoid passing around objects unless you are doing something specific. You should avoid using generics unless you have a good reason to use them. And there are plenty of good reasons to use generics, and there are plenty of good reasons to pass around object parameters, especially when dealing with things like reflection. But at the end of the day, you should always have your code be as explicit as possible and as straightforward as possible. And to get the behavior of bleh that I want, I could simply tell the compiler explicitly, by specifying the vector2 as my parameter type, that I want the compiler to ensure that I don't pass anything into bleh3 that isn't a vector2. That won't work with bleh10.
Well, it will, because you're passing it into bleh, which is
right.
The one with an object.
Yeah, this example is something I didn't want, specifically. I didn't want this to work. This shouldn't work. In fact, although invoking bleh with these parameters will work, I may not invoke bleh3 with these parameters. That would be an error. That's the compiler telling me, well, you said that you wanted a vector2, you're passing it into int, there's no conversion from an int to a vector2, so, well, do not pass go.
Yes, you'd get an error if you just passed go in.
Yes.
Public dollars, pass go. Anyway, sorry. Is it about that time for a break, I think? And if anyone's got any more
there's
questions, they can pop them
in. Yeah, because actually we're about to jump on more stuff that would require more.
Well, unless you've got anything else to say about explicit and implicit casting.
Yeah, I really don't have much more to say about it, other than this is what the syntax looks like. It's awkward. It looks awkward when defining it, but it can be very useful. And it's particularly useful when dealing with math-type stuff. I do want to point out, though, that explicit and implicit operators should not be abused. And I'm going to get more into that discussion when we talk about operator overloading. Because operator overloading is one of those things that people think they're being clever when in fact they're obfuscating their code.
I love the way how you obfuscate the word obfuscating.
So what do you want to pass into bleh3? Exactly what I specified as vector2. That's kind of like my point I was talking about. This entire discussion kind of got sidetracked. The initial discussion was just a matter of why doesn't this work? And it doesn't work. But then I wanted to point out, well, you shouldn't be writing code like that anyway. You should really just be writing that. Is bleh3 supposed to cast something to a vector2? No. There's no casting involved with bleh3. Which is nice, because now I can invoke bleh3, and I can pass in a vector3. Cast it, of course. And that will work because I have an explicit operator from vector3 to vector2.
Bleh3 is just a method like all the ones you've come across before. I think this is one of those cases where you're probably overthinking it now. If you actually look at just bleh3, it takes in a vector2, doesn't return anything, and writes out a console write line of the x component of vector2.
Okay, there's one more thing that I actually want to go ahead and show everyone or talk about really quickly. Implicit operators may be abused. Please never do this. Can anybody tell me why this is bad design? Not necessarily. I mean, you guys have some good points, but it's not really what I was looking for. I'm looking more from a design perspective of this code and how the nature of conversions and why this isn't a very good design.
I would say you're just leaving way too much to chance by letting...
In effect, I am.
Basically, no matter what, your passing code is going to be hundreds and hundreds of lines long to account for every conceivable way that somebody might want to write down a vector 3.
Yeah, and that's kind of leads in exactly to what I was saying, or trying to get at. The conversions are not parsing. A conversion is when there is one logical way to do one logical thing. There's one logical way to go from a vector 3 to a vector 2. And there's really one logical way to go from vector 2 to vector 3. However, there are an infinite amount of logical ways to go from a string to a vector 3. An infinite amount. This code shouldn't even be in the vector 3 class. Because there's so many different ways to parse a string into a vector 3, that code should be in its own component, a component that you instantiate external to the vector 3 and use. So the reason why this is bad is because the input can be interpreted in an infinite amount of ways depending on your use case. Whenever you specify an implicit conversion operator, you are locking it down to one way of doing the conversion. One way of doing the conversion. It's just like if I had a method in vector 3 called public static vector 3 from string. I wouldn't want this in the class either. I would have each way of parsing a vector 3 be in its own class, as not to break SRP, and to prevent myself from locking myself into a single way of representing a string or representing reading from a string to a vector 3. Remember, this is not a conversion, this is parsing. Difference being, a conversion, there is one logical way to do it. Parsing, you can do that, that's very subjective.
Which actually nicely rounds us back to the most basic example you gave right at the beginning of ints to floats to doubles. There is a logical way of converting an int to a float. You just add a decimal point afterwards. That's it, done. You know, there is no way you can necessarily convert the other way because, well, what does it do with the remainder?
Yeah, you would lose information. So, yeah.
But truncation isn't the only logical way of doing it. In fact, mathematically, it's not the way it's done by default. Mathematically, you round to the nearest.
Right. So, yeah, do not abuse operators. Another instance where I wouldn't recommend... Actually, this is an instance where I am on the fence of, and that is from a string... or from a vector 3 to a string. I will typically not do this, and the reason I won't do this is because there is a very handy .toString method available on every single object. But also, for example, what if I did this? What does this even mean? What does converting a vector 3 to an int mean? Am I getting the vector's length? Am I getting the sum of all the components? Am I doing any number of arbitrary mathematical operations that can be performed on 3 float components and return a single value?
Yeah, because I mean, although getting the magnitude of it seems like the obvious logical thing to our brains, because they're used to dealing with three-dimensional space, and that's just, you know, well, that must be the length of it. But yeah, just because that seems the simplest thing to do to us, doesn't mean it's any better or worse than getting the total of the lengths or, you know, any other thing.
Yep. Furthermore,
but I think... Karen.
Oh yeah. Well, furthermore, you can't go back from this. This isn't a conversion because you really can't even go back. It's not even the same information anymore. See, this is the same information, even though in this case we get some truncation, and in this case we get some arbitrary value being passed in to satisfy the third component. There still is sort of a logical correlation between a vector 3 and a vector 2.
Well, absolutely, because we are getting components that are actually the same
Name.
You know, we're getting X from X and Y from Y.
And in this case, we are doing an operation which isn't reversible, first of all. You can't, I mean, it just doesn't make any sense.
Non-commutative. Non-commutative is the phrase.
I'm not even going to try to say that word.
Yeah.
Okay. So, and like what Flash said, basically what I'm saying is don't do stupid stuff. Alright, so I'm going to go ahead and pause the video. Okay, and we're back. So, what are we going to talk about? We're going to be talking about operators. Operator overloading. This should be a fairly straightforward concept for anybody to kind of grasp. Operator overloading is the ability to overload operators in .NET. And that's really about it. Okay, so
what happens if you try now in main to add 2 of your vector 3s? That's as easy as you'll get.
what is the output to this program? You know, I really need to turn off IntelliSense.
Okay. Why is there an error there? I should have made you do multiply. Because there are actually 2 different ways of multiplying vectors.
Well, I get an error because there is no addition operator between vect1 and vect2. Vector 3, no vector 3 can be added to another vector 3. So, how do we do that? We do that with operator overloading. What does operator overloading look like? Well, public, static, operator,
Wrong one.
left-hand side, right-hand side. And, of course, I'm missing the return type. Now, what is the output to this program? Besides, of course,
It's a message that says Nelson failed.
now what is the output to this program?
If you actually say it out loud, that does make more sense that way around.
Yeah.
Because it's an operator that returns a vector 3.
Right, well, yep.
For a start, read the question, because console.writeline sum.x
Correct.
FLH. But good attempt.
Okay, so what's going on here? We have overloaded the addition operator. What's interesting about overloading operators? Well, there is a lot. I highly encourage people to, if you are interested in doing a lot of operator overloading.
Mathematicians take note.
Yeah. Well, if you're doing a lot of operator overloading, I'm serious. Read the specification.
It does get convoluted.
It gets really complicated as far as the rules that govern how you can overload operators. Now,
Oh yes, you've got a syntax error, by the way.
Line 30.
On line 36, Y.
Derp.
Right-hand side dot Y.
Well, I meant to do that. Okay. So there are a lot of rules about operator overloading. It'll typically work the way you expect it to. But we can do a lot of fun stuff. Like, for example, I can have public static vector 3 operator multiplication, vector 3 left-hand side, int right-hand side. Return new vector 3 left-hand side x times RHS, right-hand side or left-hand side y times right-hand side, and then left-hand side z times right-hand side. So you'll notice that I'm capable of having an operator that takes in one type on the left-hand side and one type on the right-hand side. So again, there's quite a few different rules. Some things are not possible to do, some things are possible to do. So for example, can anybody guess as to why this doesn't work?
It just knows.
Right. It needs, no, it doesn't necessarily need to return the same type that it takes in.
I think segfault might have... excuse me.
Well, right. What happens is that we have an operator that does not take in one of the enclosing types in its parameter list, which is obviously going to be slightly problematic. That being said, like I said, the rules of operator overloading get complicated. You can take in the enclosing type as the right-hand side if you want to. Not only that, you can do.
Presumably that's because it doesn't make any difference to the multiplication operator which one's which.
True.
Traditionally.
Yeah.
AB equals BA. Of course, when you're dealing with vectors, that's not necessarily the case strictly mathematically. But sorry, I'm having a hard time separating these from. I was looking at that going, where's this dot products and blah.
But what we get here is a very convoluted bit of code where we have, in this case, we can return any type we want from an operator overload. Almost all operator overloads. I'll get into that in a second because there are some fun operators you can overload. And the enclosing type may be this second parameter passed into the overloading method. So for example, and then basically what happens now is we get a lot of weird behaviors. So I can go ahead and say var vect or var woe equals vect1 times 2, but I can also say var hey equals woe times or 2 times vect2.
So what's the output of this?
Okay, what's the output of this program?
I just wanted to say it before Nelson. I wanted to ask people before you finish typing, in case you immediately hit F5.
What is the output to this program?
No, it isn't.
Are you guys sure about that?
Segfault. What have you done with segfault?
I don't know.
I don't believe that you're segfault.
I'm waiting for segfault to get the right answer at this point, because nobody has gotten the right answer yet. And you should know.
Segfault, you officially have permission to get the right answer.
Yeah, and I'm putting you on the spot right now, because I'm not going to move forward until you get the right answer, because you should know this one.
I'm going to sit and stare at you. Sire is the monkeys. Oh, I see.
Oh. Well, that's not it. I mean, that is close, segfault, but you're missing something.
Well, for a start, there's 2 right lines.
Okay, I'm just going to hit it at 5 because segfault got it half right the first time and half right the second time. So. We have console application 1.vector3, which is the default two-string implementation of any type, followed by hey. Because as you notice, if we multiply a vector 3 by a integer, or an integer by a vector 3, we get a string back. So, I'm not going to get into more of the rules of operator overloading. It gets very complicated. I hope people can sort of see now why things are getting sort of weird. Keep in mind that hey is a string. So you'll notice that it cannot implicitly convert string to vector 3 if I try to use explicit typing. That's because the order of the parameters do matter, the types of the parameters do matter, and the return type does matter. Okay. Notice how when I remove that, I now get an error saying that multiplication cannot be applied to integer in vector 3. So yeah, this is crazy stuff. There's a few important things that need to be kept in mind when talking about operator overloading in C#. The first one is unlike certain languages, you may not overload operators such as this.
Really?
Nope.
Why on earth not?
Well, it gets a little bit more complicated, obviously.
That's not an answer.
By overloading the multiplication operator, we have implicitly overloaded the multiplication assignment operator.
Ah, cool.
There's no way to actually do this explicitly. So, for example, that means that I can say vect1 multiply equals 20.
Oh, that's all right then. You had me worried initially. I thought you meant it wasn't. Yeah.
Well, it's not that it's impossible, it's that what the compiler does. The compiler turns this into vect1 equals vect1 times 20.
Yeah, that makes sense.
And it does this for all of the mathematical operators. There's no way to overload any of the mathematical operator assignments.
And that makes sense because they're not, I mean, they're just, I hate this phrase, syntactic sugar.
Yeah.
Now, what about the increment decrement?
Those are overloadable.
Okay.
So let's go ahead and talk about stuff. So, there are many overloadable operators in C#, and there are many operators that are not overloadable that you might think are overloadable because of your knowledge of other languages. Here are the overloadable unary operators. Addition, or not addition.
That is addition.
Well, no, it's the unary form of it.
Plus.
Yeah, the unary form of this is actually a no-op. Honestly, like there is an operator.
Because it's plus 0.
It's the most worthless operator ever.
Oh, you said unary.
Yeah.
Oh, okay. So plus and minus then.
Yeah.
Well, no, they are actually, you know, the plus one is kind of implicit normally, if you think about it. What is the tilde operator mean?
Tilde operator?
That you just put in?
Well, it's an overloadable operator. It's an overloadable unary operator.
What would it do to an int?
It's some sort of bitwise operation. I can't remember off the top of my head. XOR. It's an XOR. No, it's not an XOR. This is an XOR.
Just tipx. Get some tipx or letraset or something and write the numbers on and the symbols.
Okay, so that's not a unary operator then. You can overload the increment, decrement, and you can also overload the true and false operators, and we'll talk about those in a moment here. The binary operators you can overload is addition, subtraction, multiplication, division, as well as the XOR operator, as well as the shift operators.
about... I'm just trying to think whether it even make any sense.
You may
Would it make any sense to be able...
also overload the and and or.
Ah.
Conditional operators. You can overload equals, not equals, less than, greater than or equals, less than or equals. We'll talk about that in a second. Because the conditional operators have some rules. You what?
No, ignore me.
You may not overload the, obviously the assignment operators. You also may not overload the bracket operator, although we will be talking about a way to do that through indexers. You may not overload the parentheses operator, unlike in C++. You may not overload the assignment operator, the member resolution operator, the ternary operator, the pointer operator, or any of the new, is, size of, and type of operators.
But a lot of those, when you think about it, there'll be very little reason to. Type of is a prime example. Why would you want to?
Okay, so we are actually getting short on time. I can't believe this. So let's go ahead and run through some of the operators we can overload. We've talked about the mathematical operators you can overload. Again, the rules for the parameter list and the return type and what gets resolved are very complicated. If you're interested, read the spec. Otherwise, it will most likely work if what you're doing is if what you're trying to do makes sense. It will most likely work the way you expect it to. However, if you really want to get into in-depth actual rules of the language, check out the spec because they have a huge section about this. Okay, so let's look at a few of the interesting operators, like the increment operator. So you can actually overload the increment operator in C# for whatever reasons that you might, well, want. Actually, I'll wait because I am about to get into a big discussion, or I almost got into a big discussion about something, but I'll wait till the end of that. So, for example, if we wanted to go ahead and do the increment operator on our vector, I could go ahead and do ++. Now, as far as the this is first of all, this is a unary operator, so we only have an LHS. And then second of all, we're going to go ahead and return out, let's say, an LHS x plus 1, an RHS or LHS y plus 1, LHS z plus 1. So now what we can do is we can say vect1 ++ console right line vect1 dot x. What is the output to this program? And we get 2, just like everybody guessed. So you can do the increment operator.
Don't ever do that to a vector, by the way.
You what? Yeah.
So don't ever do that to a vector, by the way.
That's leading into a discussion that I'm just kind of saving to last. Another interesting operator you can do is the unary true operator. Now, what's interesting about the unary true operator is you must also implement the unary false operator. Okay, so what does it mean for a vector to be true? Well, I don't know.
Not 0? Just for something to... No? That's mental. Ah, yeah, atomizer. Atomizer nailed what you'd have to do if you really. I mean, if you were implementing sort of C++ style, for example, you would take the magnitude of the vector and decide whether it was greater than or equal to 1.
Yep. Okay, what's the output to this program? we get hey. That's because we are now allowed to use our object in if statements directly. See, normally we wouldn't be allowed to do that.
For very good reason.
Cannot implicitly convert console application vector 3 to bool. But now we can.
And because vector 1 exists.
Now notice how this doesn't define an actual conversion. There is still no conversion between a vector 3 and a bool. So we cannot say vect1 equals false, but we can use vect1 in any context in the C# language where it specifies that the result of the operation needs to be a Boolean.
Yeah, I mean the result of it is a Boolean, but it isn't.
Yeah.
It's still a vector.
So you can do some...
Okay, that really hurts my head. I don't like that at all. You just chose a horrible example there. But Nelson, how do we compare things for equality?
Well, we're getting to that. Because I do want to...
Oh, you said we were going to do it today.
Well, we are going to do it today.
And I've been looking forward to this for 3 courses.
Well, we have to do structs first, actually. We have to do structs, and I have to get something out about operator overloading. I'm not going to be talking about... We'll get to indexers last, because that's easy and fun. And we're losing people. I'm not going to get much more into overloading operators. We will be talking about overloading equality operators once we get into talking about equality. But for now, that's it for overloading operators. This is what the syntax looks like. Look at the spec. There are nice tables as far as overloadable and non-overloadable operators and all the rules. And as far as operator overload resolution, check out the spec on that. Okay, so...
One thing that I would say is probably a caveat to a lot of the things we've discussed so far in this particular course, which is that don't go looking for reasons to do this.
Exactly. And I've seen people do stuff like this.
Oh.
I've seen people do that. They thought, well, you know, if I add an order to a customer, then I should get an invoice back. No.
If our invoice equals new invoice,
Yeah.
sending in a customer and an order. But yeah, I mean, this is in all seriousness, and particularly with these, for goodness sake, don't go looking for most of the ones that make sense. In fact, all of the ones that actually really make sense have been done and are built into various engines. Unity's got its own math handling stuff. You know, any maths class will do a lot of these. And secondly, you know, really ask yourself why you're overloading this and whether it makes any sense at all. Really makes sense, because...
And making sense, and again, this leads back into the conversion. Making sense isn't just making sense necessarily. Well, it is. That's the first part of it. The second part of it is, can there be any confusion as to the operator you're overloading? There's only one way to add 2 ints together. There's only one way to add 2 vectors together. But there's more than one way to multiply 2 vectors together. Right.
In fact, there's 2 ways to do it. At that point, you need to separate it, which is why you will find like math dot dot or mathf dot dot for doing dot operations and using multiply for the other. Sorry, brain fail.
Okay, so yeah, that's it about operator overloading. It's something that I wanted to introduce to people. I wanted people to introduce the syntax. I specifically wanted to show the true and false because you can do some fun stuff with these. Otherwise, though, just keep in mind, don't, like Gav said, don't look for a place to use this. If it makes sense, it makes sense.
Although Metanol did say, so when would you use them? A better way to put it is, can you give us an example of a useful case?
Well, particularly for things like anything that's related to math, it makes sense to use them. To be honest, I rarely overload operators unless I'm implementing points or rectangles or other sort of mathy type constructs. Operators tip...
And even, I was going to say, even then, you would only really be doing that if you only want, for instance, if you only wanted the ability to have vector 3s, or you would choose to make your own rather than going to a math library that's already been built and optimized beyond. Because actually, if you start digging into optimization code, which I did for a brief while, it's scary stuff. And there's not, until you've been programming for another few years, you're not going to get your head around what the most optimal ways of doing things, because you're using bit shifting and all sorts of other tricks.
Alrighty. So we do have to go ahead and move on. So that was the first hour of, or the first 45 minutes of what I wanted to cover.
Cool. We're coming up on the 2-hour mark. Do we want to break as it's a convenient break point?
Let's go ahead and talk about structs first. I want to get structs out of the way, because then we can start talking about equalityness, and then we'll end off with indexers. Yay. Structs. What's a struct? Well, a struct is a user-defined type. Structs are interesting. They have many limitations, and though they do have some interesting aspects to them. And yeah, so let's go ahead and talk about them. If I create a struct called, let's say, vector2, and do public int x, public int y, let's talk about the first limitation of structs. Now, I would ask everybody to go ahead and type out the constructor of what this struct constructor should be, but I don't think anybody will get it, and they'll know
I have a question.
It's a trick question. You what?
I also have a more basic question that is just in the case of reminding people, but lines 9 and 21, are they public or private, each of them, as it stands now? Or internal, or protected? Wow. I thought that would be... That's a good job I asked that then. Nelson, do you just want to go back over that?
Over the default accessibility, you mean?
Yeah.
Right, well...
Because we've got a variety of different answers there.
The default accessibility of members like this are going to be internal. So both of these, the accessibility of vector2 is internal, the accessibility program is internal. Although that doesn't impact the accessibility of the members. So keep in mind in C++, the default accessibility of structs are public and the default accessibility of classes are private. But in C#, because we have to specify every accessibility member, every accessibility modifier directly.
On a per member basis.
It's not going to make a difference. But as far as the struct or the class itself are concerned, both of these will be marked as internal. Internal is like public, except for once you start talking about other assemblies. Okay, so this code will fail. This is the #1 stumbling block of people who work with structs. I'll get into a discussion a little bit later, or very shortly, about why you would want to use structs and the biggest differences between the two. But I want to clear up a lot of misconceptions that people have about structs and a lot of frustrations that people have about structures. And the fact is, this code will fail for a very important reason. In addition, this code will fail too. Line 14 will fail. Line 18 will fail.
Surely line
13 will not fail.
Oh, well, you've changed them. Did you say 22 will fail?
22 will fail, yep. Line 13 will fail, 18 will fail, and 22 will fail. 3 most important things to keep in mind with structures. First of all, No inheritance. Structures cannot inherit from anything, nor can they be inherited from. You can implement interfaces with structures, but we'll talk about that later because that leads into a discussion about boxing. Second of all, you may not provide a default constructor, you cannot, sorry, I'm getting confused myself here because structures are obnoxious. You cannot define a default constructor for a struct. The default constructor for a struct, every struct will always have a public parameterless constructor that initializes all fields to 0.
To 0 specifically.
Or to their default.
Their relevant default.
Yep. So for built-in types, that will always be 0. For other structs, that will be the result of invoking their parameterless constructor. And for reference types, that'll be null. Thirdly, this code fails for a non-obvious reason. But it's the number one tripping... Well, this is the third thing that people trip up on. First thing, people think they can do inheritance. You cannot. If you want to do inheritance, do not use structures. Second thing...
So kill that off.
Do what?
So kill off the inheritance then.
Yeah. Okay. Second of all, you cannot define a parameterless constructor. Now, this code fails for a very interesting rule with structures, especially how they relate to automatic properties. Whenever you define a constructor for a struct, you must always specify an assignment to each one of the fields of the struct.
But surely we've done that here.
But we haven't.
Ah. Because an automatic property has a thing called x.backing or something, doesn't it?
It's an unspeakable. So it's like bracket backing field or something like that. So all constructors on a struct must specify a value for each one of their fields. Now, the biggest stumbling block is when using automatic properties, because we cannot speak the automatic property's name, or the backing field of the automatic property's name, sorry. So how do we fix this? Given that every struct always has a default constructor that assigns the parameters to each, or assigns all the fields to defaults, and given that we cannot have a constructor that doesn't assign defaults to all of the fields, how can we get a constructor in a struct to work with automatic properties?
I actually have no clue. I was going to say, just don't make it to a normal property.
Use this syntax, quite literally. This is syntax that you can use to invoke a constructor on a type prior to the constructor that you're working on.
And so then you can use the properties because the backing fields that are unspeakable have already been sorted. Ah, nice.
So that's the number one thing that people get confused on with structs.
So what's the number 2 thing?
Well, the number 2 thing is the default parameter, or default constructor. Number 3 thing is no inheritance. Okay, so let's talk about another thing, another aspect of structs. What makes a now that we've gone through some of the stumbling blocks of defining a struct, everything else is pretty much the same with classes, as far as defining members and operator overloads and all of that stuff. But there's an interesting aspect of struct.
I was about to answer Wolf's question, but I felt I was probably being really cruel just to type yes.
This is the only difference that's specified, or the only behavioral difference, or, well, there's a few behavioral differences, but this is the most important behavioral difference that's specified about structures compared to classes. What is the output to this program?
Do you want to answer, Wolf, while people are working on that?
Yeah, a backing field is, remember these are just automatic properties. It's syntactic sugar for the C# compiler actually creating a field behind the scenes and then wiring up the properties to work with the field.
It's one of those actually. I mean, it's the backing field. It's the
field that backs the property.
Yeah. It's the field that would exist if this was a normal property where the property had, get return value, but field dot value and set value equals thing.
Okay, if I run this program, I get 1. The reason I get 1 is because of the most important difference between structs and classes. And that's because, structs are value types. Like enums, or integers, or floats, or doubles. Because structs are value types, they're passed by value. What that means is that this mutate method is receiving a copy of vect2 and mutating the copy, which means the original vect2 is unedited.
This will cause you confusion if you're not sure on this and you're trying to use struct.
And there are a few rules of thumbs about structs that I'll get into actually in a moment because those are very important.
See, I'm kind of, although not quite exactly the same, that's not a word, although not quite exactly the same, what K73 just said basically sums up my attitude to structs. I've basically gone, I'll use a class.
Yeah, and we'll talk about that in a little bit too. But I want everybody to go ahead and give me the output to this program. Now keep in mind a variety of things about structs. First of all, is position ever instantiated? Second, what is position? In fact, what are properties?
You should so teach a Philosophy 101 class. What is position?
Well, indeed, what is position? Does it ever get instantiated? What are properties? And all right, well, let's just lead through these questions one by one. So, everybody, what is does position ever get instantiated?
I was going to say, show everyone the answer and then see who can work out why it is what it is.
Oh, okay, fine. Answer is 0. Okay. Position...
So who knows why?
Yeah. Well, think about it.
Well, yes, I know why. I'm trying to be interactive.
Okay, so...
It's a new thing for me.
So that's the first question, is position is instantiated because it's a value type, meaning the memory available for position is acquired when we instantiate woe. So there is no null reference exception. You cannot have null reference exceptions with value types. But now, what are properties? Can anyone give me a really succinct answer to what a property is? Well, Segfall pretty much said it. They're methods.
Oh, I misunderstood the question. Nice little wrapper around a field.
Yeah, well, but the wrapper itself is a method.
Yes.
The get method on a property turns into a method that looks like this. What is the behavior of returning a struct or a value type? Yeah, exactly. It returns a copy.
Sorry, I got it.
Meaning, when I do hey.position, I am getting a copy of what the backing field of position contains. So then when I invoke hey.position.goForward, I am moving forward on a copy and not the actual position I intended to. Furthermore, there are some interesting limitations on structures themselves in regards to member access. If I do hey.position.x equals 20, now of course IntelliSense gave the answer away, but we cannot do this. Now of course you could say, well, hey.position should return a copy of vector 2, and then I'm setting the copy's x value to 20, and that would be logical. But the C# compiler team was like, well, if they're doing this, it's probably a mistake, so we're going to have an error being thrown.
And this is exactly the same thing that happens with vectors, I mean mathematical type vectors, in Unity, or X and A, I believe, although I can't recall properly. But certainly in Unity, the vector 3s are of this type. Excuse me, my throat's really died today, it seems. But you will get exactly this error and this message.
Is that saying structs are immutable? No, structs are not necessarily immutable. This is a mutable struct.
This is what? Did you say this is an immutable struct?
A mutable struct.
I'm not getting it. It's just a little unclear on the recording as to whether you say this is a mutable struct or this is an immutable struct.
What is the output to this program? So now you see how by having a mutable struct, having a mutable struct, we introduce situations that sometimes work and sometimes do not. This is why you should never write a mutable struct. Ever. Ever. Ever.
Ever?
Ever. No mutable structs ever. Never.
Like Will said, but sometimes, yeah?
No, never. Even if you look at the .NET framework, all of the structs defined in the .NET framework are immutable themselves. For example, can I change the value of this integer without reassigning it? Can I change the value of this datetime without reassigning it? Now, certainly I could do this.
But that's just assigning it to something else. You're not doing anything to DT.
Exactly. Because the add days method is going to return an entirely new datetime.
In fact, you could do DT add days, whoa.
Sure. And I can also chain these up.
Just to drive the point home even further, yeah.
This results in the instantiation of 3 separate structs and does not result in the mutation of any of them. So structs are passed by value. That is the most important concept of a struct. There's a very common misconception about structs
That they're evil.
that I want to clean up right now.
You're saying they're not evil.
I'm not getting into whether or not they're evil quite yet.
Not quite yet. We'll come to that later. That's in Theology 101.
Derp. Okay. On line 36, position. That is a member of this class. Is the position member of this class on the stack or the heap? Okay, line 38. Is this vect local variable on the stack or the heap? The correct answer is that I don't know. Seriously, I'm not kidding. It's not defined behavior. Whether or not the C# compiler or the CLR decides to place something on the stack or the heap is a implementation detail of the compiler and the runtime. It's not something that's worth even caring about. I would just want to point that out, because that's the number one misconception that people have about structs, is that they'll always be placed on the stack and thus more performant. But as we see here, we can quite easily get our vector2 struct to be placed on the heap by simply instantiating this.
He asked us that because, as he just said, many people have this assumption that because they forget what they know there's a difference and they forget what it is, so they make the assumption that it's a stack heap thing, and it's not.
It's a copy by reference versus copy by value. Okay, so now I'm going to step back from the trick question. The answer, people actually answered all correctly. In the Microsoft implementation of C#, at least for this version, this object will be placed on the stack, and this object will be placed on the heap, as in this property of this object will be placed on the heap, and so on. What about this? So I'm going to step back from the, I just wanted to point out that it's not useful to think about that, because I want to point out one more case where it's not useful to think about that.
Did you mean to leave that as a vector 2? Vector 3?
Okay, so I know that I said that it was kind of a trick question earlier. I swear this isn't a trick question at this point, because I'll specify this. I'll specify this question with, given the implementation of Microsoft's C# compiler and CLR that people are seemingly familiar with, is vect1 most likely on the stack or the heap? Or more appropriately, is it possible for vect1 to be placed on the stack? Like, is it physically possible for that to happen?
Is line 40 absolutely correct?
Yes. Remember, I'm talking about vect1 right here. Is it physically possible for...
Yeah, that's why I asked.
Is it physically possible for vect2 to be placed on the stack?
Sigfus's being leaked.
Ooh, Jason's back.
Right.
Yay. Is it physically possible for vect2 to be placed on the stack?
Thank you. I was just sitting here waiting to finally get... You guys stabbed me back.
Oh, sorry.
Sorry, I didn't see that.
It's so good.
Okay, well, let me actually clarify this question a little bit better here. Okay, now is it physically possible for vect2 to be placed on the stack? It can't be. There's no way for this to be able to be placed on the stack because I'm hoisting it into a lambda and returning that lambda as a delegate from this function. Meaning if vec2 were to be placed on the stack, the second I invoked the delegate that was returned by the hey method, I would be pointing to memory that is no longer available.
So, pick one of the many new words that you introduced in that sentence.
No, we talked about...
Hoisted.
Well, we have talked...
Because I know that's where you were intending to go at some point tonight.
Yeah, we've talked a little bit about hoisting before, where what's happening here is we are hoisting this local variable into this lambda. Meaning that what the C# compiler actually does is generates a class for us that contains this local variable, instantiates the class, and then uses that class to keep all of the local variables of this method in scope as long as the delegate is still referenced. So does anybody have any questions about that?
Hang in there, Wolf Nightly. It'll get better the more you're exposed to it, I promise.
I mean, we did spend quite a bit of time talking about delegates and lambdas and return types and stuff. We did talk about hoisting before, where what we have here is a situation where you can't necessarily rely on the memory location of anything in regards to value types or reference types. The only behavior that you can know for certain is that value types are passed by value and reference types are passed by reference, which is inherent in their names. So is everybody sort of understanding why this gets placed or has to be placed on the heap? Now I did say that whether or not something gets placed on the heap or the stack is an implementation detail and can change from compiler to compiler and runtime to runtime, but there actually logically is no way for this to be placed on the heap or on the stack.
Yes, don't do that right at the end on the stack.
Because the stack frame of hey goes away the second the function returns, or the method returns. And if the stack frame of hey goes away, and the vec2 local variable is on the stack, that means this memory is no longer going to be accessible, meaning when I invoke action on line 37, it's going to be pointing to invalid memory. That isn't good. So obviously the excellent developers on the C# compiler team introduced the concept of hoisting, well, to the language itself, not to the programming community as a whole, so that we can keep this local variable in scope as long as the delegate that the local variable is hoisted into stays in scope. All right. So there are a few other things about structs I want to go ahead and talk about before we talk about the general design of structs themselves. First of all value types can be boxed.
This will, however, cost extra. You get a ribbon on top and everything.
What's interesting about this code right here is that we are passing an object by value into a reference type. Remember, objects are reference types, but structs inherit from object. Another interesting thing would be this. If I had another method that took in an I_my_inner, Keep in mind, interfaces are reference types, but we are allowed to implement interfaces in structs. Meaning, I can invoke my method and pass in a vect1, and if I run this code, I get the correct output. So what happens if you print whoa and hey? Well, if I print whoa and hey, I get this. I get a console application 1.vector2, as in the default implementation of the toString method. There's actually something going on behind the scenes that allows this to work. So keep in mind that value types are passed by value and reference types are passed by reference. But value types, structures in particular, inherit from a reference type and can implement reference types. What happens when we invoke these methods is what's called boxing, which is another sort of implementation detail of the language itself. However, boxing does cause adverse performance in certain scenarios, and so it is something to keep in mind. I just want to point this out to people.
What scenarios are they? Presumably when you're dealing with large data structures.
Right. When you're doing a lot of like enumeration, like if you're enumerating over an array list, keep in mind that array list has objects in it. What happens is that every time that you try to access a value type from an array list in a for each loop, you will result in an unboxing operation, which takes time. So what we have right here in line 41 and 42 is a boxing operation, where this object gets literally packaged up. It gets a object header, and it gets placed in the heap. By default, value types, and again this is another implementation detail, but typically, by default, value objects do not get what are called object headers. They are just, when placed in memory, a vector2 will only consume 8 bytes, 2 32-bit integers. Meaning, by placing a vector2 within program, we are only increasing the stack frame of main by 8 bytes. However, typically, when you lay out an object or a reference type in memory in C#, what you get is an object header, which is a little bit of overhead that all objects in .NET or in the CLR get. And an object header, the most important thing that's in an object header is a pointer to that object's type. So that at any time the CLR can query an object, check its object header, find out what type it is, and then perform any operations it needs to based off that. So by packaging this up into an object on the heap with an object header, we can shoot it off to methods that expect either interfaces that are implemented by our value type or object references.
I've got so many questions about this that would drag you way out of the scope of this. It's just like I'm trying to sort of go, no, I can't answer that.
Okay. So are there any questions so far about structs? We've gone over a lot of the different limitations, some of the misconceptions, and some of the interesting implementation details behind them. Yeah, aren't you guys glad we're not doing architecture today?
Are we going to make it through equality or not?
We have to. Like I said, I don't want to spend any more time doing features for the next 3 weeks.
Agreed.
Cool.
Okay.
Well, how much more have you got to cover?
I'm about to finish up structs, then we'll go on break, and then we'll have about another 30 minutes of class.
Cool.
Okay. So, more considerations about value types and structs in general. Value types cannot be null unless you make them nullable. We talked about nullable in a previous class. For those of you who weren't in previous classes, for example, I can do a vector2 nullable by adding this little question mark modifier right there, and doing whoa and assigning it to null. So, Nullable stuff works with structs just like it works with enums and other value types. Last consideration, comparison. This will lead us into our discussion after we get back from break, but I wanted to point out, I did it again, didn't I? See, I started with vector 2, and then I was like, well, I need another vector. I'm just going to increment this number. So I'm going to make it make sense now. Vector 1.
That's why I do vector A, vector B.
There is no default ability to use the equality operator on structs. Now there is on classes.
Because what exactly does it mean?
Well, right. There's.
I mean, in the case of the vectors, it is actually. I mean, you could probably come up with quite a logical answer, but this obviously has to apply to any struct.
Right, and for reference types, it's easy because a reference type, the default behavior of the equality operator is to compare to see if they're the same reference. But because of the nature of structs and value objects, it's quite possible for value objects with the same members or the same values within them to be, at different locations of memory. It just doesn't make any sense, really, to compare the memory location of value objects. Because typically, they will never be the same, if you think about it, because value objects are copied by value.
Yeah, exactly. What you're comparing will be the values that are held within those objects, rather than literally whether it is the same
memory address
list of exactly the same memory address, the same ones and zeros.
Yep. So you can do this. Okay, so that was really all I wanted to get through. I wanted to get on structs as far as syntax goes. I wanted to go over the limitations of structs. And just to reiterate, structs cannot inherit from anything, although they can implement interfaces. You may not override the default parameterless constructor of a struct. You must specify every single field in a struct constructor. And in the case of automatic properties, the only way to do that is by deferring to the default constructor during construction. Next.
Can I just clarify on that subject? If you remove 21 and 22 there, would that fail then?
No, it'll still work. Because by deferring to the default constructor, all of our fields are already being set, so that constraint is already satisfied.
Yeah, that hadn't occurred to me until just then. That's why I brought it up.
Another thing, never make mutable structs ever, 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 ever. That will cause you pain and misery.
So that should be nuked, really.
Well, this should be nuked, and then this should be turned into private set. As far as when to use structs, structs can be useful for certain types of optimization if you know exactly what you're doing. And you have performance metrics that indicate that a piece of code has a problem. That's pretty much it, from my perspective at least. I don't use structs very often because of the limitations, because the syntax isn't very much the syntax is similar enough to classes, but with additional limitations. And
it's worth...
Sorry.
I keep thinking you've come to a full stop. I was going to say, because K73 said, until I watch this video again, it still sounds like classes are greater than structs in all cases. But what you have to bear in mind is that certain things built into the language are structs.
Right.
It's not just, you still kind of need to know about this, even if you have no intention whatsoever of using one. And you really shouldn't have that intention. But, even because I'm kind of with you there, but you have to remember you can't avoid them altogether. They exist in the language already.
Exactly, especially if you're reading other people's code or trying to debug other people's code when they made mutable structs or something other like that. It's silly. Wow. That sentence all came out in the wrong order. So basically, yeah. Structs are interesting. They can do some performance optimization in some certain circumstances, although, like I say, with all forms of optimization, you shouldn't ever worry about it unless you notice a problem or can prove there is a problem. Other than that, that's just all the considerations they have to keep in mind when working with structs and value objects in general, really.
Would you generally choose structs for DTOs?
No.
No.
I typically always use classes for DTOs. Out of habit.
Okay. Okay. Would one? That was what I meant.
You could. The problem that I would have with that are the amount of copy operations that would be done with the DTO, because DTOs are usually slung halfway across your system through many different methods and many different other things, that it would leave a bad taste in my mouth to see that many copy operations when I could simply use a class which simply results in a single dynamic memory instance or dynamic memory allocation.
Cool. Thanks. Data transmission object, basically a load of values, just a load of...
Yeah, that gets shot around the program. Okay, so I'm going to go ahead and we're going to go on break. Yep, and we're back. All right, so I'm going to write out some code real fast. Public int x, or public float x, public float y, public vector2 float x, float y, x equals x, y equals y. Var v1 equals new vector2 1 1, var v2 equals new vector2 1 1. If v1 equals v2, console write line equals else console write line does not. What is the output to this program?
Boom.
If I run this code, we get does not. And the reason is that by default, the equality operator in C# compares by reference. That's an important thing to keep in mind. So how can we go about fixing this? Well, the first step, a first naive implementation, may be something like this. Public static bool operator equals vector2, left-hand side, vector2, right-hand side, return x equals right-hand side x, and LHSY equals RHSY. Now, I'll get a compiler error here because we must implement the inequality operator if we implement the equality operator. So, does not equal, and then I'll do if it does not equal RHSX or does not equal RHSY, then do that. Okay.
Can anyone spot a problem with this?
Well, what's the output to this program? It builds. What's the output to this program? We get some equals, we get some does nots. Oh, people are asleep. Usually the Monday class is the... Well, unless I broke everybody's brain by now. Okay, I run this code, and we get equals. I'm not worrying about equality of floats at this point. Obviously, I wasn't intending this to be the case, but one of the reasons why this is a naive implementation is equality of floats is a bit more tricky than what I have right here. But that's not the point. The point is this now works.
Well, from what you said, this now works badly.
Or actually, I'll do this. What's the output to this program? I know that most people should be able to infer this based off my nature.
Yeah, I was going to say, surely that question should be, what's the output of this program and why?
Yeah, why is that the output of this program? Why do I get does not? The reason is what we're talking about earlier with operator overloading. There's no way for us to determine, or for the C# compiler to determine which method to invoke, given that both these parameters are objects. It's impossible. There's no runtime check on the equality operator. When the equality operator, all operators are resolved at compile time. So the C# compiler says, well, you have an object here and an object here, so I'm going to use the default object comparison, which defers to reference comparison. And because both of these references are different references, they're different objects, we do not get the behavior of our operators up here. Furthermore, another stumbling block that people typically have is in the case of interfaces. If I make an interface called iBle and implement iBle on vector 2 and change my objects to being iBle, what's the output to this program? And the answer, of course, is still does not. This is something that people get tripped up on all the time. They're using the equality operator to compare two interface references, but that's impossible because these interfaces could be implemented by a variety of classes. The C# compiler has no way to determine that it should be using these operators instead of the default. There's no such thing as virtual operator overloading by nature of the fact that operator overloading is all static. And there's no such thing as, well, static overloading. No, you cannot overload staticness. You cannot override staticness, excuse me. You can certainly overload static methods, but you cannot override them. And because you cannot override them, there's no way to do any virtualness. So this gets into an interesting method available to us on the object class itself. Remember, all objects have these members. All objects have equals, get hashcode, get type, and toString. We can override equals, get hashcode, and toString. We're going to be talking about equals and get hashcode because those are the two things that are, well, pertinent to our discussion.
Relevant at the moment, yeah.
A better implementation of this is to actually override the equals method. So now I can do public override equals. Instead of returning base.equals, I can return this. So this is a better implementation. Or, well, it will be once I fix it. The problem with there's two problems with this. The first of all, this isn't a static method, this is a virtual method. And second of all, we're comparing against an object because equals only works on other objects. It doesn't work on automatically vector 2s. So the first thing we need to do is check to see if the type of the object passed in is a vector 2. So I can say var RHS equals obj as vector 2. If RHS equals null, return false. Then I can simply compare our local properties to the RHS value. Now I also have an interesting thing that I can do with this, in that I can go ahead and make our operators actually implement or use our equals method. But this comes into an interesting discussion about reference types. I'm actually going to leave that hanging for a second here. I'm going to leave some redundant code in here. Right now this code is redundant. There's a way to get rid of this redundancy, but we'll talk about that in a moment. Atomizer, what's the problem with that? Why is this code not something we would want to do? Because the left-hand side may be null. This code could result in a null reference operation, or a null reference exception.
Exception.
But we'll talk about a way to fix that in a moment here. So now what we can do is, instead of saying object1 equals object2, we can now say object1 dot equals object2. So now the output of this program will be equals. Or, more appropriately, wait a sec. I'm confusing myself here. Give me a stack trace. Oh, right. Can anyone tell me why this code throws an exception?
Because you failed.
I did fail. Let's step through the stack trace. If I go ahead and place a breakpoint on object1 dot equals object2 and hit F11, notice how we jump into the equals method as expected. Now watch this. RHS equals obj as vector2. When I do RHS equals null, what we do is we jump into our implementation of the equality operator. With the right-hand side being null and the left-hand side being our vector2. So we get an exception. So how do we fix this? Well, what we could do in here is, instead of saying if RHS equals null, we could do if RHS is vector2, or if not RHS is vector2, return false. Otherwise, and I'll take off this actually, hold on. I'll go ahead and set if not object is vector2, then return false. Otherwise, set RHS to vector2 of obj.
Which is fairly standard sort of boilerplate code.
Right.
In many situations.
So now when we run this...
If it's null, do one thing. If not, then carry on.
So now we get what we want, equals. But there are a lot of problems with this code. The most obvious problem with this code is going to be that we have redundancy with the equals and the not equals. Another problem with this code is our equals and not equals methods do not count for null. Both of these methods operator overloads will throw an exception if the left-hand side or right-hand side are null, which obviously is not something we want. So let's go ahead and write out some code for dealing with equality members of reference types.
Well, see, given what you've just said, my next question would be, well, why don't you just, before returning at lines 35 and 40, do null check?
Well, I could, but I want to go ahead and reuse our existing code for now. Like that would be a valid implementation. I could do null checking right here. I could say if LHS equals null and RHS does not equal null, return false, and so on. You know, I could do that, but then it would become...
Well, if LHS or... Yeah, if LHS is null or RHS is null.
Well, unless they're both null. Because if reference equals LHS, RHS...
Oh, yeah, of course, if they're both null, then you want them to return... Yeah. Although you haven't talked about reference equals, have you?
Nope. Reference equals is a static method on the object type, meaning it's available on pretty much any context that you work on unless you're working in static. The object class has two methods on it, equals and reference equals. Reference equals does exactly what it says it does. It says that if the reference of LHS equals RHS, then it returns true.
i.e. literally, are they the same thing in the same place in memory?
Right. Because obviously if I did this, I'll get a Stack Overflow. Because it'll be recursive. Okay, so let's go ahead and implement these correctly. I'm going to return in my equals operator equals LHS and RHS. And then for my other method, I'm going to return not equals LHS and RHS. The equals method is again is a static method provided on the object or the object class that will appropriately defer to our equals method.
And this is where it starts to get a little confusing, he said optimistically. But remember, the one we were talking about just now was left-hand side dot equals right-hand side. This is equals taking in left and right.
Yep. And the implementation of this method, I'm just going to copy and paste it over. The equals static method, which again is actually just an alias, it's just going to be object.equals. It's a static method. It's not a method on this type itself. It's a static method on object. There's the implementation of the equals method. The equals method first checks to see if the left-hand side is the same reference as the right-hand side. If it is, it returns true. It next checks to see if either of them are null. If they are, it returns false. Finally, it returns object A dot equals object B, meaning it'll delegate to our equals method.
That is, I would say, for me, that is the key thing to that little bit of flow of logic is key to understanding this.
Right.
Because with all the different methods called equals, it's one of those this-that situations again.
So basically, at the end of the day, these two equals method identifications are going to delegate to our equals method, given that both of LHS and RHS are not null, and they're not the same reference. Because if they're the same reference, it just returns true, obviously. Then this equals method ensures that the right-hand side is a vector 2. If it isn't, it returns false. Then it finally does the true equals comparison right there. So now, finally, the last bit is that I'm not going to do object1.equals object2. I'm going to do object.equals object1 object2. This is the correct way to do equality checks on, or one of the correct ways, there's actually quite a few of them, but one of the correct ways to do equality checks between two polymorphic types.
Did you specifically choose the type name rather than the keyword there for object? So it either would work.
Yep. Okay, how's everybody doing so far? Because right now, this is a solid implementation. We're missing a few things, but this is a solid implementation of equality. And whenever you do equality, this is the bare minimum of what constitutes a solid implementation.
Yeah, I was going to say this is the simplest useful thing that you would ever need to do, really. This is about as simple as it would get without it having already been done for you within the language, is something that's got two parts to it that you need to check.
Actually, I do want to do one more check on this. The equals method, although in this case already checks for null, you should also check for null within the equals method itself. So you should also do this. If reference equals null object, then return false. And then if reference equals this object, then return true. You should redo this check because it's not always going to be true that we got here through an object.equals invocation.
It's one of those, in most cases it will be a redundant check, but there will be occasions when you can get this far without having done it.
Yep. Okay.
But then, sorry, carry on.
So yeah, so at this point, this is the basic implementation. Now there are two more things that are important. First thing is whenever implementing equality members, you should always implement the equitable or equatable of the type that you want. This interface right here is very important. All this interface does is it provides a type-safe equals method. So you'll notice that this is not a type-safe equals method. We have to make sure that the right-hand side is the same type that we want to compare. This is a type-safe equals method. This interface is used by the container types and many other types in the .NET framework. And the great thing about it is that it's potentially faster in the case of dealing with value types, because it doesn't have boxing.
Okay, I have a suggestion. If you start over and do a vector something else, vector 3, that you haven't done yet, and do it in the way that you would put it together if you were putting it together, because you've kind of got to this via a lot of things that you wouldn't do. You've put up a lot of code and then chopped it and changed it around. Show how you would do it if you were given the type. If I came to you and said, I need a vector class. I need a vector 3 class now, quick. Yes, I know, but that we'll get to that off video, or at least at the very end. But seriously, I think it would be helpful because we've kind of got to this around the houses, and it doesn't really represent the thinking you would have in any production situation.
True.
So, could you go to a
Well, I'll just
blank
redo this.
CS file and give us
I'll just redo this one.
Oh, yeah, just.
So basically,
But do it from scratch.
what I would do is I would implement equatable of type vector 2, and I would get an equals method right here. What I would do with this equals method is I would make sure that other is not null. And then I would make sure that it's not ourselves. After that, I would simply return x equals other.x and y equals other.y. So that would be the first step, is this is the true equals method. Then I would override the equals method on object. I would do a few more checks in here. First of all, I would repeat the checks of null and this as well. I'm just going to copy other as there. I would repeat the checks of null or this. Then I would make sure that it's the same type. So I would say if object dot or if other get type does not equal type of vector 2, return false. If all of this is true, then I would return equals vector 2 other. Meaning I would do all these checks to make sure that it's not null, it's not this, and it's not any other type. Then I would defer to the equals method I just wrote, my true equals method.
That deals with the specifics of whatever class you're in.
Then I would go ahead and implement the operators. So public, static, bool, operator, equality, vector 2 left-hand side, vector 3 or vector 2 right-hand side, and I would return equals left-hand side, right-hand side. Then, of course, I have to also implement the other operator. And I would return the inverse of equals left-hand side, right-hand side. And what I would get is the appropriate way to handle equality members. With one caveat, there's one thing I'm missing, but it's not directly related to equality, so we'll talk about that in a moment. But this is how you would go ahead and write out a proper implementation of equality for now.
these four methods are the bare bones of any equality comparison. Obviously, it depends on the number of things in there. So if, for instance, you had a vector 3 version, obviously that would include a public float z with a get set. So then you have to return x equals other x, y equals other I, and z equals other z.
But the most important thing to realize is...
But the framework is the key. Sorry, yeah. Don't die, we haven't finished recording.
Still alive. Kind of. Okay, so how's everybody feeling about this? Silence.
Yeah, absolutely no feelings about this at all. Oh, like what Segwall said about you being still alive.
No.
Meh. Oh, yeah.
Remember, all of these other methods are just cruft. In fact, everything but this is cruft. This is the only important aspect.
It comes down to if you can conceptualize what makes your particular object that you've made equal, what it actually means for these two things to be equal. Now here we're dealing with a vector 2, and it's fairly straightforward. Equality means that, well, the x value is the same for both, and the y value is the same for both. If you had a car that had a particular size of engine and was left or right hand drive and had 3 or 5 doors, then each of those things, essentially every variable that is important, that is important when you're considering whether two things are equal, you need to include in line 31, for want of a better way of putting it. You sound like I've said something.
Well, no. What you said is all correct, but I did actually want to launch into a quick discussion about when it's appropriate to do equality. And
basically, my rule of thumb is whenever IntelliSense, and that's not Resharper, whenever IntelliSense tells me your code doesn't work because there's no equality operator.
Well, as a more rule of thumb, what you should really do is objects that are entities. An entity is an object that has a unique identifier. For example, a person is an entity. A person may have the same name as another person, may live in the same address as another person, may have the same color of hair as another person, but conceptually that person is not the same person as another person with all those same properties. But let's say that you make a value object for address. So you make an address class. An address doesn't have an ID. An address is defined by the sum of its components, meaning that, yes, in this case, person A and person B are two different people. You shouldn't use equality members to identify or to equate on anything but the identifier. But in the case of an address, two addresses are the same if they share the same data. So, yes, a person always has a GUID stamped on the back of their neck. So, keep that in mind. So don't go overboard on equality members when it's not appropriate to. Although it is appropriate to in a lot of situations. Ask yourself.
What go overboard with equality operators?
Huh? Well, just...
You said, don't go overboard with equality operators unless it's appropriate to.
I love the English language. What I'm saying is that think about what it is that makes two things equal. Two people are not the same if they share the same attributes, whereas two addresses are the same if they share the same attributes. Two vectors are the same if they share the same attributes. But two accounts in a database are not the same if they share the same attributes. So just keep that in mind. Okay, there's one more thing that we need to talk about with equality members, and that is the hash code. Every object in .NET has a method called getHashCode. GetHashCode is used for, well, a variety of optimization things. That was, oh wow, variety of optimization things, really, Nelson? A variety of different optimizations within the BCL. For example, the dictionary class uses the hash codes of your objects to optimize access to the dictionary. Unfortunately, we can't really get it. I wanted to get into the specifics about how dictionary actually work, but we don't have enough time for that. But keep in mind that whenever you do equality members, you should always include the concept of a hash code. Implementing a hash code is as easy as implementing the getHashCode override, which is simply a method that returns an integer. What a hash code should do is a hash code should always return the same value if all of the values in the class you're in are the same. So if x and y, if x is 1 and y is 2, getHashCode should always return the same number. If x is 2 and y is 3, getHashCode should always return the same number. Now I kind of cheated on this implementation because I kind of had Resharper do it for me on another monitor. But let's go ahead and talk about a basic implementation of getHashCode. In this case, I'm going to say return x.getHashCode multiplied by 397 XOR y.getHashCode. What this is in effect...
Where did you get 397 from?
Resharper got it for me.
Where did Resharper get 397 from?
No idea. I'm actually...
I was actually going to say, does it matter how you define your hash codes as long as they're unique for the particular type?
Well, yes. Like, for example, I could simply say return x plus y. That would work, but it
wouldn't be guaranteed unique.
Yeah, but hash codes can collide. And when I say that, it means there is the possibility for two objects to have the same hash code even if they're not the same. But collision should be avoided as much as possible, because for every hash collision, there's every bit of optimization you get from using hashes to store in dictionaries and stuff like that is pretty much lost. So by returning, int x plus int y, this won't cause any bugs when using vector 2s in dictionary, because it will be the same value for every thing with an x and y, but it'll also provide a lot of collisions, because if x is 1 and y is 2, or if y is 2 and x is 1, that'll return the same hash code, which isn't desirable. You want to make your hash codes as spread out as possible. And of course I do unchecked here to ensure that I don't get a overflow exception.
I'm presuming that 397, off the top of my head, sadly I don't know, is a prime number, because that would be a logical thing to multiply by and then XOR to get something unique.
Yeah.
It sounds like it sounds like somebody's being flooded.
I can't hear a word you're saying, I'm sorry.
What is that?
That is a jet.
Is that at your end? Oh, wow.
I live, there's a
That's low.
There's a Navy base
Yeah,
island south of me, and they like flying jets over my city sometimes.
This is great. We've got like one armed service each. You've got the Navy. I've got the Army with their Chinooks flying over my shed.
Alright, now that that's gone, sorry about that. Okay, so getHashCode is very important for a variety of optimizations, particularly when using stuff like hash sets or dictionaries. And I would love to get into the implementation of the actual algorithm used for hash sets and dictionaries, because that stuff's lots of fun, but unfortunately we don't have time for that.
I do have one question about the getHashCode override, which is that now you're overriding, so there is a base method there, which is presumably why it was quite happy to compile and carry on without putting in the getHashCode override.
Right. The default implementation of getHashCode
Mm-hmm.
The default implementation for Git hashcode
Alt into insert.
is... well, I can't tell you because it's an internal call. Something within the .NET framework actually implements Git hashcode, but I'm unaware of its default behavior because you should always specify it manually.
Cool. I just wanted to check that because obviously it did work before you put that in, or at least seemed to. Do you want to? Is this the last subject we're covering in the video tonight?
We're going to look at indexers.
Oh, okay.
Which
I was going to say, I wondered whether to round it off, you wanted to just show how you would go about using Resharper.
Yeah, I'll show that at the end.
Okay, cool.
Okay, how's everybody feeling about equality members? Does everybody understand?
They've all gone off to download Resharper.
Does everybody understand what each one of these methods do, why they're needed, and why you should use them in certain circumstances?
Remember what I said way back when we first were talking about equality this evening, which is that there's a lot of code to write for these. You know, you got 4 or 5 different methods, and some of them override, some of them this, that, and the other. But it's hard. Line 39 is actually, with the possible exception of line 28, the only one that really matters.
Right.
Well, so, you know, that's the one that is dependent on the specific thing you're doing. All of the rest will essentially be, to stop me if I'm saying the wrong thing here.
Well, it'll be all the same, with the exception.
More or less the same, with the exception of the type, wherever the type appears. So instead of vector 2, you would have whatever type the enclosing class is.
The only other exception is when doing equality members on structs. There's a lot of different different ways you could write this when working with structs. Obviously, you wouldn't be doing like null checks, for example.
Yeah. And like Jisoo said, REST is error checking. It's kind of shortcutting and covering
preventing exceptions.
Craft that needs to be done, yeah.
Because at the end of the day, because line 39 is really the one that matters, we'll want to make sure that by the time we get to line 39, other is a vector 2 and it's not null. So that way we won't get a null reference exception. Okay, let's talk about indexers. Indexers are very straightforward. There's not a whole lot of new amazing things to do with indexers. An indexer, let's say we have an inventory and we have products.
Sound like an inventory.
Yes. An indexer looks like this. That's it. By creating a property that has the name of this, followed by brackets, followed by a parameter list, we have a property that allows us to, well, do whatever we want to give it these parameters. So for example, I can say console write line getting blah. And then I can say up here, console write line setting blah ID to blah value. So now if I instantiate inventory, if I do inventory bracket 20, or var product equals inventory bracket 20, the code that's going to be invoked is the getter, with a 20 being provided as a parameter. If I do inventory 10 equals new product, the method that's going to be invoked is the setter.
Which should make sense, really.
The only difference between this and a normal property is that indexers are parameterized. In that, we can pass parameters into the properties themselves. Although notice how indexers do not have a name. We access them through this bracket syntax, just like you would do with a dictionary or an array or a list.
I think a dictionary is probably the closest conceptually, because it's not necessarily the others like arrays and lists. It's the actual position index in the list. Do you know what I mean? Whereas with the dictionary, it's the unique identifier.
Yep.
Key.
Two more things to note about indexers is you can have as many parameters as you want. So by specifying a string bleh, I can now pass in 20, whoa, or 10, hey. Finally, another interesting thing about indexers is you can have them on interfaces. So for example, I can specify that this interface, anybody who implements this interface needs a product indexer with an int ID and a string bleh that has a getter and a setter. Is any of the syntax confusing?
I hope it's a blessed relief after the equality operators. Because it's one of those remember it rather than understand it. It's very conceptually straightforward. You've just got to remember what the syntax is.
Right. And it's just a property with the name of this, followed by a parameter list. That's it. And you can access those parameters from within the getter and the setter of the property. That really is it. Can you override an indexer? You can override it through inheritance, and you can overload it as well. So for example, I can have a public product this double test if I wanted to.
See, I'm glad you said that, Dave, because every time somebody asks a question that involves the word override or overload, my immediate response is how many is are there in that sentence? Do you mean the opposite?
Well, I've gotten into the habit of just answering both.
Both, yes.
That was why my answer was, yes, you can override it, but you can also overload it.
The question, if we assume all questions of that type are, can you over it? Yeah.
And that's it. Indexers allow you to index your objects. Allows you to use this square bracket syntax. This is why there is no operator overload for the square bracket syntax, as there is in C++, because it's provided to you by this syntax. And that's it, really. There's not much more to say.
Did you see Leif Arvid's question earlier, which I don't particularly want you to say yes to, but more to explain why it's not a valid question?
We'll be seeing a lot of examples of LINQ starting next week.
Because from now on, Nelson's allowed to use LINQ because he's explained it.
Well, I'm allowed to use LINQ.
LINQ is one of those things which is a complete paradigm shift in how you program, as opposed to something used in very specific circumstances.
Right.
It's a different way of writing things like for each, loops, if, statements, and various combinations of things like that. So it's more of coming at the same problem from a slightly different direction rather than coming at a different specific problem. Does that make sense? Because I'm guessing from your name that you are probably better at English than most English people, but it's not your first language. I'm not being patronising to you. I'm aware of. I have a particular way of speaking that isn't necessarily easy to understand.
All right, I'm going to take the lack of questions as well. Time to show the equality operators implemented in Resharper. So, you've watched me build the Vector 2 and Vector 3 classes without Resharper all day. Let's go ahead and write one with Resharper. So I'll start with class vector2. I'll
Don't go silly fast.
go ahead and
to make the point.
I'll go ahead and hit Alt Insert Enter to generate a constructor. Float X, Alt Enter down Enter, float Y, Alt Enter down Enter, Alt Insert E space Enter, and there we go. And I'll set both these to private.
So, hands up who now wants Resharper. This is why I've been looking forward to this for like, what is it, 2.5 courses now. Because just to see Nelson have to actually write it out longhand.
This is quite painful.
Because as I was saying before, the only thing that is generally speaking specific to what you're doing is that one line that checks each of the necessary parameters. Actually, can you go back a bit, Nelson, until it's so that all your equalities have gone away and show the actual dialogue in detail and walk people through
It's going to be Alt Insert, and then I hit E to jump down to equality members. And then what you can do is you can choose which things constitute equality, which will typically be all of your public properties, which is why it's nice to have focus on this at first, because you can just hit space to check all of them. And then you also have the option to implement IEquatable, the interface, and the option to implement equality operators, and advanced, which, well, is kind of irrelevant. So then if you hit finish, you get all this code.
I'm just trying to think, if, for example, your vector2 class also had a name property, you might want to get rid of the equality operators before doing this.
Right. If it had a name, what I would typically, whenever I add a property to something I have equality members for, I just nuke them out. Alt insert E space enter.
Well, see, what I was going to say was, I was trying to think of something off the top of my head, like name, where you wouldn't necessarily want to include that in your equality.
Right. So then, at that case, I would just check X and Y and hit enter. And so now you'll notice that this only does X and Y, as well as the hash code only does X and Y. Whereas if I had done what I normally do, Alt Insert E space enter, notice how now it's checking the equality of name, as well as using name to get the hash code for it.
I just thought that was worth pointing up, because there are situations where, like names are a primary example, where even if they are identical, because yeah, I mean, this is the sort of thing where you are looking at, you know, if this dot position equals other's position, it doesn't matter what the two names are. If their position is the same, then you want to do something.
Right.
In which case you only want to check some of the parameters. And it's about, again, as I said before, it's about really thinking about what equality means on your particular class or struct.
Yeah, it's going to be different for everyone. Or potentially different for everyone.
Most of the time, though, you will want everything checked. Because that is, you know, definition. Everything's the same.
Alrighty, so I'm about to go ahead and wrap up. We covered a lot of stuff today.
Do you want to pause for, say, 5 minutes and give people a chance to cogitate and ask questions, in case any of the questions are the things that you might want to put on the video?
Yeah, we can go ahead and pause. Alright, and we're back. So no questions came in. As far as homework this week, I want people to, especially people who missed this video, to go ahead and go through it, because the odds and ends of the syntax that we covered isn't something that I'm going to want to spend a whole lot of time on in the future as we start actually, well, writing code. So
I think we're going to have to start putting in a general caveat that if we mention something that's been covered in a previous course, we really have to start assuming that people have either seen that course themselves, or can go and look that course up, or can use Google.
yeah.
And because otherwise we're going to forever be going back and explaining what a struct is or what. When it comes to people asking questions where I feel the response should be, we've already covered this, I feel a bit awkward just saying we've already covered this, because it sounds rude. But
True, but we're going to have a lot of code that we're going to be writing, and there's not going to be a whole lot of time. So yeah, so to all the people watching the video, we'll see you guys later. Bye, future people.
Bye, future people.